topic for today is solving exponential equations by finding a common base. What makes an equation exponential, again, is where the variable is. Now we're shifting the variables to the exponents. If I were to give you something very simple, like 3 to the x equals 9, we all understand that, well, just because you're used to numbers, and these are the numbers you've worked with since you were little children, 3 squared is 9. We know that. So this is an easy one for us to start with. But what I'm going to do is I'm going to rewrite 9 as a base 3. Because when I look at it like this, I can see this similarity here. When base 3 to what power is equal to base 3 to the second power? It's painfully obvious that this x has to equal 2, or you're not going to get the right answer. That's the premise behind using a common base to solve exponential equations. We're going to force a common base. Let me give you another example real quick here. So here's an example. 5 to the x plus 1 equals 5 to the fourth. And because the bases match, because these match, the exponents become the relevant piece to the equation. Because what I understand is that no matter what, this term here, this x plus 1, better be equal to 4, or these aren't going to come out to be the same thing. So my exponent then becomes the equation to solve. X plus 1 better equal 4, which means x is equal to 3. You can check these on the calculator. That's the beautiful thing. If I put 3 in for x, I will get 5 to the 3 plus 1, which is 4. I'll put that in my calculator and I'll get 625. 5 to the fourth, 625. Okay? Although this one you don't really need the calculator to check. So here's an example. Again, one step further in our thinking. I have 2 to the x plus 3 here and 8 to the x minus 1. Now this is a little bit more of a challenge because these are not written as a common base. However, I know that I can write 8 as base 2. And so that's going to be my goal. I need to rewrite 8 as a power of 2. And I know that 8 is the same as 2 cubed. What that will do for me now is I will have 2 to the x plus 3 on the left, I don't have to touch that one, equals 2 to the third, which is my 8, raised to the x minus 1. Okay, so what I've done is I've taken this 8 to the x minus 1, and I've rewritten 8 as 2 cubed, and I've just plugged it in there. So 2 cubed is my 8. Now, rules for exponents. We know when you take a power to a power, you multiply the exponents. Be careful because that's binomial. So what this means for us now is that I have 2 to the x plus 3 on the left equals 2. I'm going to multiply those to the 3x minus 3. And now that the bases match, I'm going to grab my exponents here and set it equal to this. So what I can tell you is that x plus 3 is equal to 3x minus 3. And if I continue to solve, I will subtract, I will subtract x from both sides and add 3 to both sides. And I will end up with 6 equals 2x. I'm running out of room because I can't extend this actually. So x is going to turn out to be 3. Let me put this up here. Sorry about that, guys. X is going to equal 3. And again, I can check this. If I take it back up into the original problem, what I'm going to do is say is 2, 3 plus 3 is 6, equal to 8 to the 3 minus 1 is 2. And if you put this in your calculator, 8 squared is 64, 2 to the 6th is also 64. So it definitely works. The nice thing about these equations that you're solving is that once you find x, you can always check them on your calculator. So it gives you that little peace of mind and security that you did it right. Okay. Here's an example. And this one's a little bit more complicated yet again because I'm going to have to adjust both sides. I can't write 27 easily as a base 9, but I can write both 9 and 27 as powers of 3. So if you keep in mind, 9 is 3 squared, and 27 is 3 cubed. And so what I'm going to do is I'm going to rewrite the rest of this. So there's my 9 to the x, and that equals 27 to the x plus 1. Now that they're both in powers of 3, I can tell you that 3 to the 2x is equal to 3 to the 3x plus 3. It's really important that when you multiply this, you realize this is binomial and it needs to be distributed to both terms. Again, my bases match now, and I can set my 2x equal to 3x plus 3. I'm going to subtract 3x from both sides. I'll get negative x is 3, which means x is negative 3. And that's a good answer. And again, you can check it if you want on your calculator. So I wrote in here for you to try. Your goal is to write them both as a power using the same base, and it makes sense that you would use a smaller power. So when you're looking at these bases and you're looking at 5 and 25 and trying to decide which one you're going to write it as, always pick the smaller integer because it's easier. So I want you to, well, this one's already okay, but you're going to rewrite this as a power of 5 and then finish the problem. When you, so pause the video, and then when you start it up again, the solution will be there. Hopefully you got x to be equal to negative 6. If you didn't, then you want to take a look at my steps. Again, one of the places people make a lot of mistakes is not distributing that to both terms. So make sure that your new exponent over here on base 5 is 2x plus 2. Set the exponents equal and solve, and you get x to be negative 6. So here's one. So this is the final type, and these are the hardest because they involve a fraction. So what you need to realize here with this fraction, I want you to just ignore the fact that you have a fraction and look at the denominator 2. And when you compare the 2 here to the 8, I want you to use the smaller of the two integers. I realize this is not an integer, but I want you to pretend for a second it's not a fraction. Between 2 and 8, 2 is the smaller number. So we're going to use base 2 in order to rewrite these as a common base. Okay? So if you think about it for a second, I need you to say, I mean, the 8's easy. That's 2 cubed. And that'll be 2 cubed to the x. But I need you to think for a second, what power would you raise 2 to in order to turn it into a 1/2? What do you think? How would you turn a 2 into a 1/2? How are they related to each other? And what would I do to an exponent to make that happen? Hopefully, you're thinking to yourself, 2 to the negative 1, because the negative says reciprocal, or 1 over. And if you did say that, then you're absolutely right. And if not, then that's okay, but the next one we do, you'll be able to have a chance to work that out for yourself. So now that they're both common base 2, I can take my product here, which is 3x, equals, and I'll take my product here, which is negative 1x plus 1. Again, remember to distribute that. When I add the 1 to x to both sides, because that's what I want to do, add 1x and add 1x, I'll get 4x equals 1. So x will be 1/4. It's perfectly legitimate to get a fractional value here for this. Okay, so don't think, oh no, I did something wrong. You didn't. Final example for our notes. And again, I want you to try to come up with this. So I do have a fraction 1/9. I want you to ignore the fact that it's a fraction and just take that numerical denominator of 9 and the other side is 27 and ask yourself, what base can I rewrite both of these as? Or what power, what's the base to which I would raise the power? Whatever the question is. So think about that for a second and see if you can come up with it. Hopefully you chose 3. I can write 9 as 3 squared, and I can write 27 as 3 cubed. Now the 27 is the easy one, again, so I'm going to do this side first. 27 is 3 cubed, and that's raised to the x minus 1. Now the 9 is 3 squared. But again, how do you get it to flip over, if you will, or reciprocate to 1 over 9? And hopefully you realize that there's a negative in that exponent, which will take it 1 over 3 squared. There I have my rewritten expressions, which leaves me with a 2x equals, again, don't forget to distribute that, 3x minus 3. And so if I subtract the 3x over, I'll get a negative 5x is negative 3, and when I divide by negative 5, I get 3/5 is my answer. Not a pretty answer, but very legitimate. For the last example, I'm not even going to have you do the whole thing. I just want you to figure out what base would you use here in order to rewrite 4 and 1 over 8 as a common base. What number would you use? And then see if you can come up with the correct exponent. So go ahead and pause it if you need to. And when you turn it back on or restart the video, again, the answer will be there for you. Hopefully you chose base 2. 4 can be rewritten as 2 squared. And 1/8, again, we're looking at just the 8. 8 can be written as 2 cubed. The negative here says 1 over. Okay, so tomorrow when we come into class, we're going to be practicing these. This is an important skill. It's typically tested on the exam, so we want to make sure that we're very, very good at this skill. Not to mention the fact that this is technically the beginning of logs and the idea and the concept of logs and what this is all about. So we want to make sure that we have these down solid.